Alright guys, in this example we're being asked to integrate the natural log of t divided by t dt. When you start thinking about what technique you're going to use to integrate this, as we typically do, we run through our typical list. First thing I always look for is there composition? Can we use the traditional u-substitution where we let the u be the inside of two composed functions? And I don't see that. I don't have natural log of t squared plus 7. It's just plain old natural log of t. Obviously, there's no composition with just the t, so that's pretty much out for this example. Is there a log rule? This pops into my mind for more than one reason. One, obviously, there's a natural log, so that kind of hints at log rule. But if you think about it, the log rule actually had nothing to do with integrating a natural log. Log rule was referring to getting a natural log when you integrated something like 1 over x, and you got natural log of x. Now, it is still a fraction, which could still hint at it being the log rule, but notice that natural log of t is not the derivative of t, and normally you have to have that format of du over u to be the log rule, and that's not what we have either. So it looks like that's out. A lot of times you can rewrite an integrand, change the way that it looks, move terms around to make it fit one of your more basic rules. I don't really see that helping too much either. You could write it natural log t times t to the minus 1. That doesn't really help either. Well, it turns out that, and the reason I chose this example was to expose you to this type of problem. This is a sneaky type of u-substitution problem. Because if you'll notice, you really have two expressions here, and maybe I could pull this natural log term over here off to the side to see it more clearly. Like if you have natural log t times 1 over t. I mean, I guess this could be a version of rewriting if we were being technically correct about it. But if you pull this natural log off to the front, which is obviously legal algebra, it seems pretty interesting to me that this term, 1 over t, is the derivative of this term. And so what we're going to do is, like I said, a kind of a sneaky version of u-substitution, where if we let u be natural log of t, then 1 over t dt, that'll be our du, and it's a perfect fit there. So all we have to do is do that substitution. We'll let u equal the natural log of t, and then the du for the expression will be 1 over t dt. That's the derivative of natural log t dt. And so when we rewrite our integral, it'll be basically just u du, right? Just u du. And this is a very simple power rule because this is u to the first. So integrate u to the first, you get u to the second over 2 plus c. And for our final answer, we'll just go back and take this u out and replace it with what u was actually equal to in terms of t. So in this case, where is it? Right here. U is the same as natural log t. Right? Now, if we check this going in the forward direction, it makes perfectly good sense. Try differentiating this term. Let's just see what we get. It's a chain rule problem. The 2 comes down, right? Power rule, 2 comes down, cancels with this 2. And so you'd have natural log of t followed by the derivative of the inside, chain rule, and you'd get 1 over t. And that's precisely what we started with our integrand right here. So we know it's correct. It was just kind of like I said, a sneaky use of u-substitution because this is one of the rare cases where there's not composition, yet we were still using u-substitution.